Hi, in this video I'm going to show you how to use Geometry Script in Unreal Engine 5 to create a procedural mesh actor that is a little patch of mesh that conforms to the landscape or whatever's underneath it as you drag it around in the level. And in part 2 of the videos, I'm going to show you how to use this patch and modeling tools to make little overhang type cave things in your environment, which normally the landscape system doesn't support because it's a height field. Okay, so I'm going to walk you through making the whole blueprint. It's not that complicated. So I'm going to delete this one. I'm going to make a new blueprint. So to make this kind of blueprint, you need to not use just blueprint class, but go into Editor Utilities and click Editor Utility Blueprint. And then here in the search box, you can type Generated Dynamic. What you want is a Generated Dynamic Mesh Actor. This is one of the built-in types that for this procedural geometry script type stuff. I'm going to name it BP Demo Patch. I've already got one made that we might have to refer to if I forget what to do. Okay, so let's go to the event graph. And I'm going to go over here to Functions, Override, and I'm going to click on Rebuild Generated Mesh. And that's going to give me this event here, which is where I'm going to generate the mesh. So the first thing I'm going to do actually, before I start wiring stuff, is I'm going to make two variables. One's going to be, we'll call it tessellation. That's how many triangles there's going to be. Make that integer, default it to say 25. I'm going to set the ranges here so that we can have the UI be nice. 0 to 100, and I'm going to set the max at 500. And then make that public. We'll add another one for size. We'll make that a float. Compile. Say default size 1500. Okay, so now we've got our setup there. That was just a bit of boilerplate. So the first thing I'm going to do is drag off this target mesh, go append rectangle. So I want to append rectangle XY. That's going to just make me a little patch. I'm going to wire in the tessellation to the steps width and height. I'm going to wire in the size to the dimension X and Y, and click compile and go back to the level, and we'll just test that out. So there we go. We've got our rectangle, and you can see we can turn the resolution up and down, change its size. So now all we need to do is make this bunch of triangles and vertices stick to the landscape as we move it around. Okay, so let's go back to the patch here. So the mesh inside of an actor is always in its local space. So as we move this around, the vertex coordinates, right, they aren't changing, but we need to do this projecting down in world space. We want to basically cast rays down that hit what's underneath this mesh. So the first thing we need to do is transform it. We're going to do transform mesh. And we're going to transform it into the world space from the actor. So we're going to go, we'll start with self, get a reference to self, get transform, that gets the actor transform. Let me put that in there. And then we're going to compile that. Okay, so now we've got now the mesh is in world space. If we go back over here, we're going to see it now. It just moves around in some weird location because it's been put in world space. We're going to put it back at the end. But now what we want to do basically is iterate through those vertices and do a line trace for each of them. So what we're going to do is get max oh yeah, that's right, get num vertex IDs. Okay, so the mesh, this is something you need to take care of when you're doing geometry script blueprints. If you want to do stuff by iterating over the vertices is in this case, we just generated this mesh, so we know all the vertices are there, but if they aren't, you might have gaps in the vertex space. So then some in the vertex ID space. So there's also get vertex count. But if you've ever deleted any vertices from the mesh, say like doing a Boolean or something, then the vertex count and the number of vertex IDs is not going to be the same. So now what we're going to do is do a for loop. And basically we're going to wire in that in there. The first index is 0. The last index is actually going to be this -1. Oh, minus. Because for loops, that's how for loops work in blueprints. They're going to include the last index. And so then in the loop body, the first thing we want to do is this target mesh here. We want to check if this is a valid vertex ID. So like I said before, we don't strictly need to do that, but we're going to do it in this blueprint because afterwards I'm going to show you some faster ways to do this stuff. So loop body, the first thing I'm going to do is branch. If it's valid, we want to do a line trace. So let's do line trace by profile. Nope. Line trace by channel. I'm going to trace complex. Okay, so now we need the position. Where do we want to trace from is the vertex location. So we need this mesh again. I'm going to put one of these in here just so I can wire it off a bunch of times. Get vertex position with that vertex ID. So that's the vertex position. So we want to trace from way above that position to way below it. So first we're going to add, I don't know, a big number. Doesn't really matter. That's the start of the line trace. And then we're going to subtract another big number. So these are just plus and minus z, right? Because we're just going straight up, straight down. So if that vertex exists, we're going to do this trace. And then if it's a hit, branch, we're going to set vertex position. So we'll get that mesh again. Set vertex position. If we got a hit, we need that vertex ID again. I guess we could just take it from here. And the new position, if we split the struct pin here on the out hit, we do out hit location at the new position. Okay, it's important. You want to check this defer change notifications. That's going to make this a lot faster because otherwise every time you do this, it's going to say to the mesh, hey, you change, you need to rebuild. And it's going to do it for every time you set the vertex position. So make sure you check defer change notifications on these kind of functions if you're doing a bunch of things in a loop. Okay, and then once the loop is over, we want to do our transform again. So transform mesh. The mesh is going to be this same mesh. I'm just grabbing it wherever it's handy, I guess. This one here. It's all the same mesh, right? It's a UObject pointer it's passing around. So it's always the same mesh. And we want this actor transform. I'll copy it. So to go back from world space to local, we want to invert that transform. And then we want to compute normals. If we type per-vertex normals, we're going to get this function set mesh to per-vertex normals. That's the one we want. Okay, compile that. I'm going to save it. So now if we go back in here, we see that our patch is sticking to the ground. And it doesn't matter where we put it vertically. You'll see it kind of jumps. That's because the rendering thread runs asynchronously. So sometimes it's rendering just before the mesh got updated. But as you can see, as we drag it around, it sticks. We can increase or decrease the resolution, change its size. You can still do things like, because we're working in world space, you know, if you scale it, you can use those kind of controls. It's still going to work. So there's the patch. I'm going to show you now one thing that will come up if you start doing this kind of stuff and maybe you want to work on big meshes. If I set this tessellation super high, I'm going to set to 500. You see now something broke. It didn't work properly. So why did that happen? That's because there's a limit on how many times a loop in blueprints can run. So if we go to edit and project settings and type the word iteration. Yeah. There we go. If you type iteration to search, you'll see maximum loop iteration count. So it's set to 1,000,000. So because we have 500 by 500 quads, we end up with over 1,000,000 things in that loop. So I'm just going to change it to 10 million. And now when we do this, it's going to work. So that's a super high res patch. You probably don't actually need that, although maybe you would in some case. So let's just reset that. Okay, so that's the blueprint. Like I said, I'm going to do the second video where I'm going to show you how to use this to use the modeling tools to kind of work with this patch. But first I'm going to show you a way to do this blueprint a little quicker using some nodes that aren't part of the default Unreal. So I make a plugin called Gradientspace UE Toolbox, and it has nodes that try to make this kind of stuff simpler. So I'm just going to go through the blueprint here again. We're going to just remake it again with these other nodes that I have available in my plugin, which you can get at gradientspace.com/UE Toolbox. I'll put links into the description. So that target mesh, the first thing we want to do is transform it into world space. So instead of having to remember like where do you get the transform and stuff like that, we've got a function map mesh, and then there's different options. So map mesh from actor space to world. That's what we want to do first. So I'm going to just change this wire. And the actor is self. So now you don't have to remember where to get the transform, if it needs to be inverted or not. Okay, so now the mesh is in the world. We want to do that for loop. So instead of getting all of this stuff, doing for loop, remembering the indices, I have a function. I'll zoom in. Hope you could actually see that other blueprint I was doing. Function for each mesh vertex. So what this does is it gives you a delegate you can make. So what you can do is you can right or left drag off of that and pick add event, add custom event, and that will basically make a little inline function here that it's going to run for each vertex. So this node, when it runs, it's going to call this wire here for every vertex that's valid in the mesh. So it handles the is valid checking, it handles the counts and everything like that. So now we can just go up here, and it also gives you the vertex position as part of the function, so you don't have to get the vertex position. So all we need from up here is the line trace, branch, and set position. We'll just copy those down here. Okay, and then the line trace, I find all the time I need to make these start and end points, which I found annoying. So I added this function, calc line trace start end. So that gives you all the stuff you need. So we have the vertex position. We want to go, the direction here is -1 because we're going to trace down. So the start dist we'll set as -9999. And the end dist, well, you can just leave it at that. It's already a big number. And then we're going to do the trace. So then we've just got our start point and end point there. We can wire right in. And then if we got a hit, we do the set vertex position. And we've got the mesh here in this function and the vertex ID we can wire over. And then same thing, we want to map the mesh back, map mesh to world from actor space. We put that same, we put ourself in there. And then we can do this set vertex normals again. Come on. So it's a little bit simpler and I think is a bit cleaner. You can make this nested part here a separate function in the blueprint and also call it there, which of course you can do in this other blueprint. There's more kind of boilerplate up there, a little bit less explicit names for things. Okay, so let's compile that and we go back, we see it does the exact same thing. It is actually a bit more efficient. This for each function avoids a bunch of blueprint calls and the overhead of a blueprint loop, but maybe has a bit more overhead running a delegate versus the other branches. I'm not actually sure. Okay, so that's this blueprint, and that's how you make this little patch. If you would like to see me develop this patch further, for example, automatically adding a skirt so that there's never a gap at the end or at the edge, or preserving like edits you might make in the middle, leave some comments and I can try to do those videos. And otherwise come back for part 2 where I'm gonna make a little cave like this using this patch as a starting point. Okay, thanks for watching.